so much time that we can talk about everything, but today we're going to focus on something that I think is really cool. It's called black holes. Black holes. And right now what you can see is the International Space Station. It's about 430 kilometers above our Earth. It's in what's called a low Earth orbit. And this is a live stream right here. So it makes an orbit around the Earth about every 90 minutes or so. So it's pretty cool to look at. And you can see in the lower left-hand corner there where there's a little dot, probably better to see on maybe a TV screen or monitor, but you can follow the space station as it goes around. And it's traveling at about 27,000 kilometers an hour in the speed. So it makes one full orbit around the Earth about every 90 minutes. So it's pretty cool, right? Just say yes. Say yes. All right, good. So I don't know, I like the study of astronomy. Astronomy is the study of the stars and planets and things like that, but I don't know a lot about it. But by doing this project for today, I've learned a lot of new things, so I hope I can share them with you.
好，你们现在看到的呢，是从太空站往地球看的画面哦。那它是一个直播，那如果你有兴趣的话，回家可以看一下哦，哈，可以，说不定可以看到我们台湾，对不对？好，那我们今天要讲的主题呢是黑洞。老师在课堂上会讲到宇宙，那我们今天要讲的主题是黑洞哦。
So we're going to first see a video about what is a black hole, and then there'll be another video after it. It's called First Image of a Black Hole, like first photo, because usually you cannot take a photo of a black hole because it's just black. But some people were able to do it, and we'll explain how that's done also.
哦，那你一边看那个画面，然后一边听老师说。
Is an area of such immense gravity that nothing, not even light, can escape from it. And of some stars' lives. The energy that held the star together disappears and it collapses in on itself, producing a magnificent explosion. Here's where things get crazy. All of that material left over from the explosion, many times the mass of our sun, falls into an infinitely small point. Black holes can form in many ways though. And large black holes can be tens to millions of times the mass of our sun trapped in a point smaller than the tip of a pin. Some black holes trap more and more material as their mass increases. The point where all that mass is trapped is called a singularity. It may be infinitely small, but its influence is enormous. Imagine a circle with a singularity in the middle. The gravity on the inside of the circle is so strong that nothing can escape. It sucks in everything, even light. That's why it's black. This circle is known as the event horizon. An event horizon is probably what you are thinking of when you think of a black hole. What would happen, you might wonder, if we took a spacecraft near a black hole's event horizon? The answer? Spaghettification. That's the technical term at least. As our spacecraft approaches, the gravity will be so much stronger on the side closer to the black hole than at the other side that it will get completely stretched out like a piece of spaghetti. Try as you may, you would be hard-pressed to find anything weirder or cooler than a black hole, presented by NASA's Space Place.
All right, so you can see a black hole is pretty dangerous. And does anybody have any idea how a black hole is formed? It's when a star explodes and then it collapses in on itself. And so it creates this vacuum that it just sucks in everything. And then this cool term, event horizon, this is also known as the point of no return. And the point of no return means that when you get sucked in, there's no way out, okay? So this is the first image of what a black hole looks like. And the light around there is going to be different types of debris. Debris is like things that are floating in space that are going to get sucked into the black hole. And the way they are able to develop this photo is explained in another YouTube video that we'll be showing. But they had telescopes set up around the world, all timed at the same time to take photos of this place, and then they were able to put them all together. But it was a long project. I think it took about 2 years for them to do, and so yeah, it'll be pretty interesting.
Jets extend out at least 5,000 light years, and one of them appears to be pointing almost straight at us. Relativistic beaming is again the reason we can see the jet coming towards us in this Hubble Space Telescope image, but not the one going away. Since the jet is pointed almost straight at us, I'm thinking our perspective is almost perpendicular to the accretion disk. But let's have a look at what we would see if we were looking at different orientations. The warping of space-time around the black hole means we can see light even from parts of the accretion disk behind the black hole. They are lensed above and below the shadow region. Not gonna lie, this is so trippy, I could stare at it for a long time. So the big question most people are going to be asking is, why is the image so fuzzy? The answer is because it's so tiny. Don't get me wrong, the black hole itself is huge, supermassive in fact. As measured from this picture, the black hole has a mass 6.5 billion times that of our sun. The actual size of its shadow is nearly the size of our solar system, but located 53.5 million light years away, its size from our perspective is only about 40 micro arc seconds. That's the angle it makes on the sky. To understand what that means, take the whole sky and divide it into 180 degrees. Then divide a degree into 60 arc minutes, and an arc minute into 60 arc seconds. Divide an arc second into 100, and into 100 again, and into 100 once more, and that is the size of the black hole shadow, only about 40 micro arc seconds. It puts us at the very limit of what we are technologically capable of seeing. In fact, to get this sort of resolution, due to the basic law of physics, the diffraction limit, we needed a telescope the size of the Earth. That being impractical, the scientists used 8 telescopes spread across the globe. They all simultaneously observed M87, and as the Earth rotated, that helped fill in the Earth-sized telescope that they were trying to simulate. But M87 was not the only black hole they looked at. They also observed the supermassive black hole at the center of our Milky Way galaxy, Sagittarius A star. They haven't yet released an image of this black hole, but this simulation shows what it might look like. It's much closer, at around 26,000 light years away, but also much smaller, with a mass only 4 million times that of our sun. It's also less active, only periodically gobbling up matter, and it would have much more variation over time, with matter orbiting every 4 to 30 minutes. That's probably why we'll have to wait a little longer to see the black hole at the center of our galaxy. For now, the striking image of the black hole in M87 confirms beyond a shadow of a doubt that black holes do exist. The general theory of relativity, published over 100 years ago, is supported again in spectacular fashion in the strongest gravities and at the limits of our ability to test the theory. What I love about moments like this is the ridiculous extreme things these scientists did, these 200 scientists, in pursuit of a goal that seemed impossible, and yet they achieved it. I want to extend my personal congratulations to everyone on the team for an amazing discovery. I'll be linking to all their work in the description.
And actually, we'll be talking about one of those scientists very soon, named Katie Bowman. She's originally from Indiana. She comes from a super smart technical family. Her father is a professor of electrical engineering. I think her mother is a mathematician. She is also. And we'll see a little bit about her later. Okay, so this is the first image of the black hole. You can see it took 200 scientists to try to put it together, operating 8 telescopes around the world. And so I think it's pretty impressive considering how far away it is. My first question now to all of you is, what is a black hole? Does anybody have an answer? A black hole, does anybody know?
老师现在问问题啊，你们觉得黑洞是什么呢？描述一下，简单的。What
Anybody
is
know black hole?
black hole？ 来，知道的人去找老师，知道的人去找老师，简单的就可以，可以得到棒棒糖
How do we get
哦。
a black hole? Does anybody know? Just think.
它是什么颜色嘛？
Start. Okay. All right, this man's got it right here. Star explodes. Right here. Right here? Okay, she's gonna come get it.
来，他答对喽，大家
All
掌
right, very
声。
good. All right, next is, how, you, it's not right, how-
Maybe it doesn't look spectacular at first, but consider this. Black holes by their very nature are invisible because their gravitational pull is so strong that not even light can escape them. So for many years, astronomers thought that an image like this was impossible. How do you take a picture of something that does not emit light? Well, it starts with a small team of innovators and ends with a telescope that is unlike anything the world has ever seen.
This is going to show you how
Now,
they were
despite
able to
major
take the
advances in
photo.
telescope technology, there is no single telescope on Earth that can take a picture of a black hole. They're all too small. So astronomers innovated. If one telescope couldn't do the job, then perhaps 8 would. And they were right. They used 8 radio telescopes stationed at different points across the world and kept them all in sync with powerful atomic clocks. They called the effort the Event Horizon Telescope. This series of telescopes combined has about the same capabilities as if you had built a telescope as large as our entire planet. And for the first time in history, it has shown us what a black hole, around 55 million light years away, looks like. This black hole is actually a supermassive black hole. It's about 6.5 billion times as massive as our sun. That's enormous even compared to other supermassive black holes, and lives in the center of the Messier 87 galaxy. And as far as experts can tell, it looks exactly like what Einstein's general theory of relativity predicted. Here's a simulation of what the Event Horizon team thought the black hole would look like. And here's the real image. The light you see here is what's called the accretion disk. It's a disk of light that forms around the black hole when a star travels too close and is broken apart in the process. But the most important part of this photo is where there is no light. That dark circle in the center, which measures 25 billion miles across. That right there is proof that black holes look and behave how astronomers thought. More specifically, that they actually have an edge. It's a place of no return, which astronomers call the event horizon. Once you cross the event horizon, the black hole's gravity is so strong that you cannot escape. Not you, nor the fastest spacecraft, and not even the fastest thing in the universe, light. That's why the edge and everything beyond it are black, trapped inside the black hole's gravitational grip. And this image may be just the beginning. The Event Horizon Telescope team has also turned its sights on another black hole, one that is closer to home, called Sagittarius A star. It's the supermassive black hole at the center of our own galaxy, the Milky Way, about 25,000 light years away. But it's significantly smaller than the one in Messier 87, so it will probably be more difficult to image. And since it took astronomers 2 years to combine and analyze data for this first image, it may be a while before we see what other black holes look like.
然后我们刚刚看到是他怎么拍那个黑洞的照片的过程哦。
Okay, so that just kind of gives you an idea about how they were able to take that photo. It took them 2 years to put it all together. One of the scientists involved is this lady right here, Katie Bowman, and I mentioned her name before. She works at Caltech, Los Angeles. I believe she's now 32 years old. She's actually a full professor of math and computer science, so pretty smart lady. And so she's just one of the people who are involved in developing the algorithm. Does anybody know the word algorithm? An algorithm is a set of specific instructions given to digital devices like computers, and that's how they all operate based on those instructions.
好，那我们刚刚看到的照片啊，就是以这一位女士，她才32岁哈，以这位女士为首的科学家，他们经过演算法所做出来的。那虽然它是一个很模糊的照片，但是它是经过很多高科技做出来的哦。
Okay, we go on to the next one. Yeah, let's go on to the next one. I think we're going to start running out of time. Yeah, okay, what are black holes? Let's try to answer that question now. They are the largest stars in space when they explode, as we found out over here. And when they explode, they collapse in on themselves. So, as I mentioned before, it creates kind of a vacuum. You see in the lower left-hand corner how the lines go, and then they start to go in. And at one point there where there's the edge, this is called the event horizon. It's also the name of the telescopes that they used for this image. And the event horizon is actually the point of no return, which means that you will, if you pass that point, you will get sucked in and bye-bye forever. But actually some things, even before the event horizon, just if our bodies were there, we're very small, we will get sucked in anyway. So it's quite interesting how that happens, and I think the diagram is so cool, and I like the term event horizon. So we have lots of supermassive black holes. Now supermassive black holes are not as active as smaller ones. And our galaxy is called the Milky Way. We have one at the center of it. And they mentioned also in the videos, it's called Sagittarius A star. And it's quite large, but it's actually also very slow at sucking things in. So we've got nothing to worry about. It's 25,000 light years away from us, which would be very, very far. Okay?
好，那大家有没有一点知道黑洞是怎么出来的？大家有没有一点知道？待会会讲到，就是星星，就是星球它渐渐老化之后会怎样哈，然后最后就是会形成黑洞。那大家现在看到左下角那个小小的图，在刚刚影片之中其实很多哈，就是所谓的那个黑洞中心的周围，任何人只要一靠近就会被吸进去的那一块区域，哦，它叫做 Event Horizon， 叫做世界。 好，然后中间那张图呢是在讲我们的银河。那大家在课堂上老师会教，在银河的正中心有一个黑洞哦，离我们很远，所以我们没有被吸进去哦。好，那我们再看下一张。
Okay, this is Sagittarius A, our own black hole in the Milky Way galaxy. That's the name of our galaxy. We call it Milky Way. And you can see in the upper right-hand corner there a slight picture with that accretion disk, but we can't really see inside the black hole very well. And we probably have to wait until technology improves so we can see it better. Okay, my question to you is, what is the name of our galaxy? Does anybody know what is the name of our galaxy?
来，老师前几天有上课的班级回答一下。我们的银河叫做什么呢 ？M 开头。
Can anybody tell me what the name of our galaxy is?
M 开头，还记得吗
Anybody know? Anybody want to take a chance? Can anybody read the last 3 words up there?
有人会是不是？
Anybody?
会的 ，raise your hand。
Just say. Right, very good. Milky Way galaxy. Can you say a little louder so everybody can hear you?
大声。
All right, very good. Here's the winner right here. Good job. Milky Way galaxy.
好，那我们的银河，来，请掌声。好，刚刚是说到银河其实非常多个哦，那我们这个银河叫做 Milky Way，Milky Way， 那就在荧幕上这个单字哈。那现在看到这个右上角这个放大图，就是我们银河的那个黑洞。
Okay, I have one other question. We have a black hole in our Milky Way galaxy. Can anybody tell me the name of it? Can anybody tell me the name of it?
来，这题很简单，答案就在上面。那一个黑洞叫什么名字？念念看。
All right, very good. Sagittarius A, right here. Good job.
就这一行的第一个字哈，那个字就是我们黑洞的名称哦。
All right, so that's the black hole we have in our galaxy. Now we have supernova. So a star explodes either when it gains too much matter means too much stuff coming in, or when it runs out of its nuclear fuel. And stars burn on their own fuel, so eventually, billions of years later, they will run out of gas just like we run out of gas when we drive a car or a scooter. So a supernova explosion can burn very bright, like we just have our one sun, our star, right? But with 100 million suns, then we would probably all go blind. So that's the explosion of a star right there.
好，那我们刚刚讲到黑洞是星球老化之后的产物哈，那这个就是它老化的第一步骤。首先呢，它会爆炸。
Okay, does anybody know what a supernova is? Can anybody read that up there? Under supernova it says a supernova is the explosion of a star. Can anybody read that? Don't be shy. Anybody? Anybody? Oh, here we go. All right, very good. Good job. Thank you. Very good.
请掌声。
All right.
好，那现在这个画面叫做超新星哦。首先它爆炸了，它叫超新星。
All right, so after a supernova, more massive stars can end their lives in one of two ways, right? We have a neutron star, where a star squeezes itself smaller and smaller, and it becomes very dense. So you can have a star that's like the size of a pinhead, but it can weigh 100 million tons.
好，那它爆炸之后啊，它渐渐冷却之后，就会变像现在这样，叫做中子星。那它是一个非常重的一个球体。
Now the other way that we can have that is with our black hole, and it's even more dense because no light can escape from it. The gravitational forces are so strong that not even light can escape from it.
然后最后它就一直缩，一直缩，一直缩，就变成黑洞了，就变成黑洞了。
Okay, next we've got some telescope images of black holes from space. This is from the Hubble telescope. The Hubble telescope is orbiting our Earth. It's not together with the space station, but it orbits the Earth. But these are some photos that are taken from that telescope. The telescope has been up in space for about 30 years now, so maybe the technology is not so good anymore, but it still sends back some very good images of space.
好，那大家有听过哈勃望远镜吗？现在看到的画面就是用这个望远